In the process capability tool, the first thing we want to do is lay in our data points, and those are they go in where there's yellow colored cells. Anytime in these templates, anytime you see a yellow colored cell, it's requiring an input from the user, so we lay in the data points here. The way I've set this up is there's 1,000 data points max. The other thing I want to put in here is my alpha, so I can calculate my confidence intervals. So once I lay in my data points, the first thing I'm going to check for is data normality. So this is using Anderson-Darling, and it says the data is normal, so I can proceed. If it says it's not normal, then I can't use the results of this tool. They'll be erroneous for a capability. But in this case, we're okay. So the data is normal. It says I've got 1,000 data points with a mean of 500.75 and a standard deviation of 37.41. The min value in this data set is 373.42, and then the max is 626, and the difference between those two is my range, so that's 252.58. Just looking down at the capability, imagine I put, somewhat arbitrarily here, but for demonstration purposes, I put a lower spec limit of 400 and an upper spec limit of 600 in, so imagine there's a spec limit sitting right there at the 400 mark on the lower spec limit, and on the upper spec limit there's one there. And any data points to the right of the upper or to the lower part of the lower, to the left of the lower, pardon me, would be defects. They would consider to be defects. I can see what my capability is at each of the lower spec limit and the upper spec limit. The Z-bench is the overall process capability. So I see that I've got a Z value or a process capability of 2.69 sigma for the lower and 2.65 for the upper. So the way you calculate those just very quickly is, for the upper I would take my upper spec limit, so in this case it's 600. I want to subtract from that the mean of the data set, in this case it's 500, and then I want to divide that by the standard deviation, and that should give us, for the upper spec limit, 2.6532, 2.6532, and then similarly for the lower. I change it around slightly though, because now I want to take the mean of the data set and subtract from it the lower spec limit, and then divide all of that by the standard deviation. And you'll see here 2.6935 for the lower, 2.6935 for the lower. So that's how you calculate the spec limits. And what it's saying then is I've got a 2.69 or 2.7 sigma capability on the lower, and a 2.65 sigma capability on the upper. Overall, I've got a capability of 2.43 sigma. And then my parts per million, so the expected defects then are 3,535, and then I've got my capability indices here is my short term and my long term. And I'm looking, of course, at the overall, not the within, although you'll use the within when you've got subgroup sizing here. If I use a subgroup size of 1, you'll notice the numbers here are identical. If I have different subgroup sizing, then I'll use the within capability. So that's the tool, and if you wanted to see the calculations behind this, you can just look off to the right, and I've put all the calculations there, but that's it. It's a very clean tool. Go into Minitab if you have Minitab, and you can verify the results here, and it'll give you an idea of what Minitab is doing and how it's calculating it. But this is the classic process capability tool for Lean Six Sigma project.